Section 259.104. 8.1 covers the bonding of interior metal water piping in a separately derived system. This differs from the water pipe bonding in a single-family dwelling. In a separately derived system, the water piping is not connected to the building's grounding electrode system. Instead, the water piping is bonded to the grounding electrode conductor of the separately derived system itself. This ensures the water piping maintains the same electrical potential as the separately derived system. This prevents electrical faults within the separately derived system from creating a shock hazard for anyone touching the water pipes. In a single-family dwelling, the water piping is typically connected to the building's grounding electrode system. This connection makes the water piping part of the building's overall electrical grounding system, which helps dissipate electrical faults to the ground. Because the separately derived system's water piping isn't part of the building's general electrical grounding system, a direct connection to the building's grounding electrode system isn't required. The critical distinction lies in where the water piping is bonded. Is it to the building's grounding electrode system, as in a typical dwelling, or to the grounding electrode conductor of the separately derived system? Understanding this difference is crucial for ensuring electrical safety in both types of installations. To elaborate, a separately derived system, often found in commercial or industrial settings, gets its power from a source isolated from the main building power supply. This isolation necessitates a separate grounding approach for safety. Bonding the water piping to the separately derived system's grounding electrode conductor effectively creates an equipotential plane, minimizing voltage differences and the risk of electric shock. Conversely, in a single-family home, the water piping, being connected to the building's grounding system, serves as an additional path for fault current to return to the source, aiding in the rapid operation of overcurrent protective devices like circuit breakers. The National Electrical Code, or NEC, outlines specific requirements for grounding and bonding to ensure electrical safety. Section 250 provides comprehensive guidelines for grounding and bonding, including requirements for water piping systems. It is important to adhere to the NEC and local codes when installing or modifying electrical systems. Proper grounding and bonding techniques are essential for minimizing the risk of electrical shock and fire. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices to quickly clear the fault. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of voltage differences that could cause electric shock. Furthermore, the size of the bonding conductor is determined by the size of the ungrounded conductors of the separately derived system. AC Table 250.102. C1 provides guidance on sizing bonding conductors. For example, if the ungrounded conductors are 1/0 American wire gauge copper, the bonding conductor would need to be at least number 8 American wire gauge copper. The connection to the water pipe must be made within 5 feet of the point of entrance of the water service into the building. This ensures that the entire water piping system is effectively bonded. The bonding connection should be made with a listed connector suitable for the purpose. The connector should be installed in accordance with the manufacturer's instructions. In addition to bonding the interior metal water piping, it is also important to bond any other metal piping systems that may be present, such as gas piping or heating piping. These piping systems can also become energized in the event of a fault, and bonding them helps to minimize the risk of electric shock. The bonding of these other metal piping systems should be done in accordance with NEC Section 250.104. It's also important to note that plastic water piping does not require bonding. Since plastic is a non-conductive material, it cannot become energized and does not pose a shock hazard. However, if there are any metallic components in the plastic water piping system, such as metal fittings or valves, these components must be bonded. Also, consider the potential for corrosion. Bonding to similar metals can create a galvanic reaction, leading to corrosion. Using appropriate connectors and materials can minimize this risk. Regular inspections of bonding connections are recommended to ensure they remain intact and effective. Over time, connections can loosen or corrode, compromising the effectiveness of the bonding system. In summary, The key difference between water pipe bonding in separately derived systems and single-family dwellings lies in the connection point. Separately derived systems bond to the system's grounding electrode conductor, while single-family dwellings bond to the building's grounding electrode system. This distinction is crucial for maintaining electrical safety and preventing shock hazards. Firstly, in a separately derived system, the primary goal of bonding the water piping is to maintain an equipotential plane within the system itself. This means ensuring that all metallic components, including the water pipes, are at the same electrical potential, preventing voltage differences that could lead to electric shock. Secondly, in a single-family dwelling, the water piping serves as an extension of the building's grounding electrode system. It provides an additional path for fault current to return to the source, aiding in the rapid tripping of circuit breakers or fuses. This helps to minimize the duration of a fault and reduce the risk of electrical fire or shock. Thirdly, the NEC provides specific requirements for grounding and bonding in both separately derived systems and single-family dwellings. These requirements are designed to ensure that electrical systems are installed and maintained in a safe and effective manner. It is important to consult the NEC and local codes when designing, installing, or modifying electrical systems. The NEC Section 250.50 covers grounding electrode systems. The NEC Section 250.104 covers bonding of piping systems and exposed structural steel. The NEC Section 250.30 covers grounding of separately derived alternating current systems. Understanding the purpose of grounding and bonding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, while bonding ensures that all metallic parts are at the same electrical potential. Proper grounding and bonding techniques can significantly reduce the risk of electrical shock and fire. Furthermore, consider the impact of electronic equipment on grounding systems. Sensitive electronic equipment can be affected by ground loops and voltage fluctuations. Properly designed grounding and bonding systems can minimize these issues and ensure the reliable operation of electronic equipment. Ground loops occur when there are multiple paths to ground, creating circulating currents that can interfere with electronic signals. Equipotential bonding helps to prevent ground loops by ensuring that all metallic parts are at the same electrical potential. When working with electrical systems, always follow safety precautions. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. De-energize circuits before working on them, and verify that they are de-energized using a voltage tester. If you are not qualified to work on electrical systems, consult a licensed electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. For example, an isolation transformer is a common type of separately derived system. An isolation transformer provides electrical isolation between the primary and secondary windings, which helps to protect sensitive electronic equipment from noise and voltage fluctuations. When installing an isolation transformer, it is important to follow the manufacturer's instructions and the NEC requirements for grounding and bonding. Proper grounding and bonding are essential for ensuring the safe and reliable operation of the isolation transformer. Another type of separately derived system is a generator. Generators are often used as backup power sources in the event of a power outage. When using a generator as a separately derived system, it is important to follow the NEC requirements for grounding and bonding. The generator must be properly grounded and the neutral conductor must be bonded to the generator frame. This helps to prevent electrical shock hazards and ensures the safe operation of the generator. The size of the grounding electrode conductor for a separately derived system is determined by the size of the ungrounded conductors. NEC Table 250.66 provides guidance on size and grounding electrode conductors. For example, if the ungrounded conductors are 3/0 American wire gauge copper, the grounding electrode conductor would need to be at least number 2 American wire gauge copper. The grounding electrode conductor must be connected to a grounding electrode, such as a ground rod, ground plate, or underground metal water pipe. The grounding electrode must be installed in accordance with NEC Section 250.52. It is important to ensure that the grounding electrode is properly installed and provides a low impedance path to ground. In addition to grounding and bonding, surge protection is also important for electrical safety. Surge protective devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes, utility switching, or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. SPD diverts surge current to ground, preventing it from damaging electrical equipment. There are different types of SPD available, and it is important to select the appropriate SPD for the application. SPD are rated by their surge current capacity and their voltage protection level. The surge current capacity is the maximum amount of surge current that the SPD can handle without failing. The voltage protection level is the maximum voltage that the SPD will allow to pass through to the protected equipment. When installing SPD, follow the manufacturer's instructions and the NEC requirements. SPD must be properly grounded in order to function effectively. Regular inspections of SPD are recommended to ensure they are functioning properly. SPD can degrade over time due to repeated surges, and they may need to be replaced periodically. The NEC provides specific requirements for the installation of SPD in Section 285. It's important to consider the potential for harmonic currents in electrical systems. Harmonic currents are non-sinusoidal currents that can cause overheating of electrical equipment, voltage distortion, and interference with electronic equipment. Harmonic currents are often generated by nonlinear loads, such as electronic ballasts, variable frequency drives, and computers. To mitigate the effects of harmonic currents, harmonic filters can be installed. Harmonic filters are designed to reduce the amplitude of harmonic currents, improving the power quality of the electrical system. There are different types of harmonic filters available, and it is important to select the appropriate filter for the application. Harmonic filters should be installed in accordance with the manufacturer's instructions and the NEC requirements. Power quality monitoring can be used to identify the presence of harmonic currents and other power quality problems. Power quality monitors measure voltage, current, and other electrical parameters, providing data that can be used to diagnose and resolve power quality issues. The NEC provides requirements for power quality monitoring in Section 220.88 for non-dwelling units. Furthermore, consider the use of arc fault circuit interrupters, or ASIs. ASIs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. ASIs trip the circuit breaker when an arc fault is detected, preventing the fire from starting. The NEC requires ASIs in many locations in dwellings, including bedrooms, living rooms, and dining rooms. There are different types of ASIs available, and it is important to select the appropriate ASI for the application. ASIs should be installed in accordance with the manufacturer's instructions and the NEC requirements. Regular testing of ASIs is recommended to ensure they are functioning properly. Test buttons are provided on ASIs for this purpose. The NEC provides requirements for ASIs in Section 210.12. Finally, consider the use of ground fault circuit interrupters, or GFCIs. GFCIs are circuit breakers that are designed to detect ground faults, which are a common cause of electrical shock. GFCIs strip the circuit breaker when a ground fault is detected, preventing electrical shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. There are different types of GFCIs available, and it is important to select the appropriate GFCI for the application. GFCI should be installed in accordance with the manufacturer's instructions and the NEC requirements. Regular testing of GFCIs is recommended to ensure they are functioning properly. Test buttons are provided on GFCIs for this purpose. The NEC provides requirements for GFCIs in Section 210.8. By understanding the differences in water pipe bonding between separately derived systems and single-family dwellings, and by following the NEC requirements for grounding, bonding, and overcurrent protection, electrical safety can be significantly improved. Remember to consult a licensed electrician for any electrical work that you are not qualified to perform. Electrical safety is paramount, and it is important to take the necessary precautions to protect yourself and others from electrical hazards. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or questions. Firstly, ensure all electrical work adheres to local and national codes, with the NEC being the primary standard in the United States. Secondly, regularly inspect and maintain electrical systems to identify and address potential hazards. Thirdly, prioritize safety by de-energizing circuits before working on them and using appropriate personal protective equipment. Fourthly, educate yourself and others about electrical safety practices to prevent accidents. The grounding electrode conductor for a separately derived system is sized according to NEC Table 250.66, based on the size of the ungrounded conductors. The bonding jumper connecting the separately derived system's frame to the grounding electrode conductor is sized according to NEC Table 250.102. Seat 1. The bonding conductor connecting the water pipe into the separately derived system's grounding electrode conductor is also sized according to NEC Table 250.102. Seat 1. The water pipe bonding connection must be made within 5 feet of the point where the water pipe enters the building, as per NEC 250.104. A1. This helps to ensure that the entire water piping system is effectively bonded. The bonding connection must be made with a listed connector suitable for the purpose and installed according to the manufacturer's instructions. All metal piping systems, including gas and heating piping, must be bonded to the grounding electrode system as per NEC 250.104. B. Plastic water piping does not require bonding as it is a non-conductive material. However, any metal components within a plastic water piping system must be bonded. Dissimilar metals should be avoided in bonding connections to prevent galvanic corrosion. Regular inspections of bonding connections should be performed to ensure they are intact and effective. In a single-family dwelling, the water pipe is typically used as a grounding electrode and must meet the requirements of NEC 250.52. A1. The water pipe must be in direct contact with the earth for at least 10 feet to qualify as a grounding electrode. The water pipe must be supplemented by an additional grounding electrode, such as a ground rod or ground ring, as per NEC 250.53. D. The bonding jumper connecting the water pipe to the service equipment is sized according to NEC Table 250.66. The bonding jumper must be connected to the water pipe within 5 feet of its point of entrance to the building, as per NEC 250.68. C. The bonding connection must be made with a listed connector suitable for the purpose and installed according to the manufacturer's instructions. All metal piping systems, including gas and heating piping, must be bonded to a grounding electrode system as per NEC 250.104. D. Plastic water piping does not require bonding as it is a non-conductive material. However, any metal components within a plastic water piping system must be bonded. Dissimilar metal should be avoided in bonding connections to prevent galvanic corrosion. Regular inspections of bonding connections should be performed to ensure they are intact and effective. Surge protection devices should be installed at the service entrance to protect against voltage surges caused by lightning or other events, as per NEC 285. Arc fault circuit interrupters, or FSIs, should be installed in all branch circuits that supply dwelling unit bedrooms, as per NEC 210.12. A. Ground fault circuit interrupters, or GFCIs, should be installed in all 125 volts, 15 amps and 20 amps receptacles located in bathrooms, kitchens, and other wet locations, as per NEC 210.8. The NEC provides specific requirements for the installation of electrical equipment in hazardous locations, such as those containing flammable gases or vapors, in Articles 500 through 516. Electrical equipment used in hazardous locations must be listed and labeled for the specific hazard. The NEC provides specific requirements for the installation of electrical equipment in healthcare facilities, such as hospitals and nursing homes, in Article 517. Electrical equipment used in healthcare facilities must be designed and installed to minimize the risk of electrical shock to patients and staff. The NEC provides specific requirements for the installation of electrical equipment in agricultural buildings such as barns and poultry houses in Article 547. Electrical equipment used in agricultural buildings must be designed and installed to withstand the harsh environmental conditions. The NEC provides specific requirements for the installation of electrical equipment in swimming pools, spas, and hot tubs in Article 680. Electrical equipment used in swimming pools, spas, and hot tubs must be designed and installed to minimize the risk of electrical shock to swimmers and bathers. When working with electrical systems, it is important to follow lockout/tagout procedures to prevent accidental energization of circuits. Lockout/tagout procedures involve disconnecting the power source and applying a lock and tag to the disconnect switch to prevent it from being turned on. The NEC provides specific requirements for lockout/tagout procedures in Article 120. It is important to use the correct size and type of conductor for each circuit, as specified in NEC Table 310.16. The ampacity of a conductor is the maximum current that it can carry safely without overheating. The type of insulation on a conductor determines its temperature rating, which is the maximum temperature that the conductor can withstand without degrading. The NEC provides specific requirements for the overcurrent protection of electrical circuits in Article 240. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from damage due to overloads and short circuits. It is important to use overcurrent protection devices with the correct ampacity rating for each circuit. The NEC provides specific requirements for the grounding of electrical systems in Article 250. Grounding is the intentional connection of an electrical system to the earth. Grounding helps to protect people from electrical shock and to prevent damage to equipment from voltage surges. It is important to use the correct type of grounding electrode and to install it properly. The NEC provides specific requirements for the bonding of electrical systems in Article 250. Bonding is the intentional connection of all metal parts of an electrical system to create a low impedance path for fault current. Bonding helps to prevent electrical shock and to minimize the risk of fire. It is important to use the correct size and type of bonding conductor and to install it properly. The NEC provides specific requirements for the wiring of electrical systems in Article 300. Wiring methods include the use of conduit, cable, and other types of raceways. It is important to use the correct wiring method for each application and to install it properly.